Hello and good morning, dear students. So today is 17th of August and we are starting with question number 22 in today's video. Okay, so this will be a new type of question for us because here we can see solve the differential equation where dy by dx equals to this. Okay, given that this is the extra thing given to us, given that y equals to 0 when x is equals to 0. Okay, I'll come to this in the later part of the question. But before that, let us solve this differential equation. Now we have dy by dx equals to 1 plus x plus y square plus xy square. Okay, so one thing I can see common is there is x, there is y square. Okay, so let us see what we can do. So first we'll write dy by dx is equals to, I want to keep these two terms together, 1 plus y square, and then from the second and the last term I'm taking x common, so which will give me again 1 plus y square. So I hope you can see 1 plus y square common. So therefore dy by dx, so let's take out the common part, that is 1 plus y square, right? So 1 plus y square, okay, and into it will be 1 plus x. Okay, so now we need to separate the variables. Let's keep dx together, and dy divided by 1 plus y square, which will give me 1 plus x into dx. So now as the variables have been separated, so now what I can do is I can take integration on both the sides. So I hope you're clear with this. So please pause the video and note it down till here. Alright, so when you integrate this, so see, I'm again showing out here integration dy by 1 plus y square. This is one of the standard integrals. Integration dy divided by y square plus 1 square, which is equals to integration of this and this. So this is tan inverse y. I hope you know this integral. Okay, tan inverse y, which is equals to x plus x square by 2 plus c. So let us keep it as equation number 1. Now what happens from here is, we have to now use this condition. So this conditions, if I use this condition out here, see what the condition is, given that y is equals to 0 when x equals to 0. So what does it mean? It means that put the value for y is equals to 0, also put the value for x equals to 0, and then we can find the value for the constant c. Okay, so the meaning of this is, according to question, y equals to 0 when x is equals to 0. Therefore from equation 1, if I substitute these values, this becomes tan inverse 0, which is equals to 0 plus 0 square by 2 plus c, right? So therefore tan inverse 0, tan of which angle is 0? Obviously it's tan 0, isn't it? And this is already 0, and this is the c. So therefore tan inverse tan 0 is 0, so hence the value of c is equals to 0. So here the constant is also 0. Therefore the final equation, the required equation will be tan inverse of y is equals to x plus x square by 2. Alright, so this is called your particular solution. Okay, solution, and this solution is called the general solution. Okay, so there will be actually two types of solutions in differential equation. The solution which contains constant, this is called general solution, and the solution which does not contains any constant, okay, is called your particular solution. Okay, so pause the video, note it down. Alright, so next we move to question number 24, part 1. Number 23 is exactly the same, so you'll try yourself. 24 is a bit different. Let us see the question. Okay, solve this question. Twice y plus 3 minus xy dy by dx is equals to 0, given to us y bracket 1 equals to minus 2. Now what is the meaning of this? Given y bracket 1 equals to minus 2. So now please do understand properly. This means the value for y equals to minus 2. This means the value for y is equals to minus 2 when x is equals to 1. Okay, this means y is equals to minus 2 when x is equals to 1. Please note it down. Again, we'll be using this in the later part of the question. Before that, we need to solve, right? So what to do? Let's take this to the right hand side. It becomes positive. Now we need to see how to separate these variables. So now what I have done out here is, see, I have to do cross multiplication first. So I have to cross multiply with dx. So x divided by x, dx divided by x, and y divided by y plus 3 I can even take this half, but for the time being I'm keeping it out here. Okay, now what to do? Integration. As it is separated, I can do integration. This side is very easy. This is twice log x, which is equals to, now how to integrate? I've always told you, if the power in the numerator and denominators are equal, I can make the numerator as the denominator. So hence I can add 3 and then subtract 3 divided by y plus 3 into dy. So now I'll separate. So this side is already solved. Log x is equals to, if I separate, then this will be y plus 3 divided by y plus 3 into dy, and minus 3 1 by y plus 3 into dy. Okay, so therefore we will be getting this as twice log x, which will be, it gets cancelled out, right? So this is only y. Okay, and if you solve it, you'll be getting log. Okay, so I'm writing this as minus 3 log y plus 3 plus c, which gives equation number 1. So this is our equation number 1. Now in this equation number 1, we'll substitute those values. Okay, so pause the video, note it down. Okay, alright, so therefore this was equation number 1. Now what we have to do is we have to use this condition, and the condition is y bracket 1 equals to minus 2, which means the value for y equals to minus 2 when x equals to 1. So you just have to put the value for x equals to 1, y is equals to minus 2. So on doing so, I'll be getting 2 log 1 is equals to minus 2 minus 3 log minus 2 plus 3. Okay, now log 1 means 0, so 2 into 0, which is 0, 0. Okay, minus 2 remains as minus 2 minus 2. Now minus 3 into log minus 2 plus 3. See, minus 2 plus 3 is 1, so log 1, so log 1 is again 0. So this part is 0, this part is 0. I'm only left with minus 2. Bring this side, it becomes c is equals to 2. Okay, so we'll be getting the value of c as 2 and put this value of c out here. This will be the final answer. Okay, 2 log x equals to y minus 3 log y plus 3 plus 2. Okay, so which is your answer. So please pause the video and note it down. So I hope now you have got the idea how to solve this type of equations. The first step is to separate the variables. Once you integrate it, then finally you have to put the conditions. Okay, so pause the video and note it down. Alright, so let's continue. So here on the board you can see 3 ISA questions I've taken. This is 2014, this is 2011, and this one is 2013. Okay, there are more ISA questions which have been solved in examples. I want you guys to follow that from your book as well. Now these 3 questions I'm taking, I'm going to show you very quickly how we can solve these questions by using separation of variables. Okay, so please pause the video and note down the questions first. Alright, so for this question, that is 2014, the first step that you do is you take this to the right hand side, it becomes positive. Now since there is dy, so try to keep y terms this side. Since there is dx, so try to keep x terms this side. Okay, which I have done out here. The moment you do this, now your variables have been separated, and now I can use integration sign on both the sides. Okay, I think this question is similar to the previous question that we have done. So very easy. This is log y, right, is equals to twice. Now you can see the powers are equal, so make the numerator as denominator by adding 1 and subtracting 1. And now what we do is we separate. Okay, so this is log y, which is equal to twice, and then when you separate, it becomes only dx and minus 1 by x plus 1 dx. I hope you're clear with this. So the final answer will be log y, which is equals to twice. This will be x minus log of x plus 1 and then plus c. So when you open the bracket, you get the final answer. Okay, I hope this was very easy for you to understand. It's same as the previous sum. So pause the video and note it down. Okay, so next one I'm taking is, this is 2011. Now this question has already come in ISC 2011. The question is very simple. If you get a question from separation of variables in ISC, a similar type of questions you'll be getting, how to separate the variables and do you know the formulas or not. Okay. Is that clear? So separation of variables also very, very important. Okay, so if this question is given to you, what do you do first? You can see clearly out here e to the power x plus y. So there is x as well as y. So I cannot do directly, okay? But yes, one thing I can do is I can break the powers. We can use the product law, which we have learned in laws of indices, isn't it? So I can break the powers in this way, e to the power x into e to the power y plus the same thing. And now you can see e to the power y is common. So take e to the power y common. So this will be e to the power x plus x squared. Now this part is your x, this part is your y. So when you do cross multiplication, dy by e to the power y and this into dx. So now the variables have been separated. So now I can use integration sign on both the sides. Okay. So this side term by term multiplication and integration. This side please take your e to the power y to the numerator so that we get e to the power minus y dy, which equals to integration e to the power x dx plus integration x squared dx. Now this also we know how to do. E to the power minus y divided by minus 1, which is equals to e to the power x plus x cubed by 3 plus c, which is your final answer. Okay, so very simple. Pause the video and note it down. Alright, so moving forward, the next ISC question I'm taking is 2013, and this is from exercise 9.4, question number 20, part 2. So log dy by dx equals to 2x minus 3y. Yes, we have to use separation of variables. During examination, it will not be mentioned use separation of variables. Okay, as we are doing this exercise based on separation of variables, so now, you know, the hint is right there in your head. So we have to separate. But during the examination, you will not be given any hint. So please do practice in such a way so that you can identify, you know, in the blink of an eye, you can identify, oh yes, this question is from separation of variables. Right? Okay. Now in this question, it is log of this, which is equals to 2x minus 3y. We know that whenever we have log of x is equals to 2, if the base is not mentioned, then the base is always taken as e. You know, I have also done this in, I think so, in indeterminate forms, right? So if log of something is equals to 2, if log of x equals to 2, then the value for x from here will be e to the power 2 base to the power right hand side. Okay, because from here, if you take log both sides, it will be log x equals to log this, right? And therefore, log x is equals to, use the property, twice log e, isn't it? And if the base is not mentioned, the base is e. And log of same number with the same base is 1. So hence log x is equals to 2. So please be clear with this. Whenever we have log x equals to 2, the value for x will be e to the power 2. Okay, so the same thing happens out here also. The base is not mentioned, the base will always be e. So log dy by dx with base e equals to this means the value for dy by dx will be e to the power 2x minus 3y, right? And now yes, we can break the powers. So therefore dy by dx is equals to, this is e to the power 2x into e to the power minus 3y, right? So now what to do? Please do the cross multiplication. So dy by e to the power 3y is equals to e to the power 2x into dx. Now, sorry, this is minus. And now if you ask me what to do, it has already been separated. So please take integration on both the sides, right? I hope this is clear. So integration both the sides, take it up to the numerator, it becomes positive. So e to the power 3y positive dy, integration e to the power 3x dx. I hope you know how to do. This is e to the power 3y divided by 3, which is equals to e to the power 3x divided by 3 plus c, which is your final answer. Okay, so please pause the video, note it down. Alright, so that's it for today. Today's assignments will be question number 23, 24 part 2, 25 part 2, and please go through all the ISC sums from this exercise, separation of variables. Tomorrow when we start a new exercise, that will be exercise 9.5. This will be doing tomorrow, exercise 9.5. Now in exercise 9.5, what we'll learn is, see in exercise 9.4, a question was given to you, we used to reduce in separation of variables, is it? And then integrate and solve. But in exercise 9.5, directly I'll not be able to do separation of variables. I have to do some assumptions we have to make, okay? And on that basis of assumptions, then only we can do separation of variables. So that we'll be learning tomorrow. And the topics for tomorrow is reducible to separation of variables. Okay, how we can reduce to separation of variables. Okay, so that is tomorrow's topic. Also, I want to tell you that now, every week there will be an open book exams for class 10 and 12 for your pre-selections. Okay, so now you have to be ready with that. Please revise all the chapters we have done from the beginning of the year. So I'll let you know when we will be having open book exams. Your class teachers will be informing you by today. Okay, so be ready for that. Not only in maths, physics, chemistry, bio, in fact all the subjects you will be having your open book exams every weekend. Okay, so please do go through all the chapters that we have done so far. And today's assignment is the 3 sums. Also go through all the ISC sums. Okay, so bye bye and take care. I'll see you tomorrow.